Number 14 looks like it's a calorimeter problem. And whenever we're doing a calorimeter problem, it's a good idea to divide the world up into the system and the surroundings. The surroundings are always water in a calorimeter, because that's what's in the cup. The system in this case is when ammonium nitrate dissolves. So you put that stuff in, it dissociates into its ions, and that's the reaction that's going on. It's just a dissolving reaction. Now, you remember, we always work on figuring out how much heat the surroundings, the water, gained or lost. And if you look up here, the temperature fell from 25 to 20 degrees. It definitely is losing heat. Well, how do we calculate how much heat is lost? Well, we need to know these things as they relate to water. You notice we need the specific heat of water, and that I believe you already know. We need to know the mass of just the water, and I'll let you figure out what that is, and we need to know the change in temperature. If we know those things, we can calculate how much heat the water must have lost. One other thing is, if the heat is lost by the water, remember that's heat going out, so the sign should be negative on your answer. If it's not, double check your work. Now, the system must be releasing heat, or must be gaining heat, because if heat is being lost by the water, it must be gained by the system. So when ammonium nitrate dissolves, it gains heat. Therefore, its value is going to be exactly the same as the Q from the water. It's just going to be the opposite sign. Now, since this is a reaction, the Q here is not just heat, it's the delta H of the reaction. So we will know the delta H of the reaction. Now, why can't we just take that number and plug it in and get it to accept it? Well, one is, you'll notice that your answer here is in joules, because the specific heat was in joules. So we're going to need to convert that to kilojoules. The other thing that we're going to need is we're going to need to do it in kilojoules per mole. And so we're going to have to take our kilojoules and divide it by the amount of ammonium nitrate that we used. And you'll notice it said that we used 4.5 grams of ammonium nitrate. So if you converted that to moles, you could divide your kilojoules by that moles, and then you'd have the answer that they want.